Systems of equations solving by elimination. So we've learned how to solve by graphing and how to solve with substitution. So this is the last method to solve a system of equations. So here are the steps over here on the left, and you can read this on your own. I'm going to go through these steps with each of these examples. Now, the important thing here to know is this method works best when both equations are already in standard form. So substitution was good if you had something isolated, like a y equals or an x equals. Elimination is good for if you have no variable that's isolated or cannot be easily solved for. So let's look at example 1. Solve the following systems of equations by elimination. So what the goal is here is we need to get rid of a variable in one way, shape, or form. With substitution, we got rid of that variable by replacing it with something else. With the elimination method, we're going to get rid of a variable by adding these two equations together and making a coefficient add to 0. So if I look here and I look at my pairs of like terms, so these are both x's, so when I add these will add together. Well, -3 plus a -4 does not make 0, so there will still be some x's left over. If I look at the y's, though, I see -5 and +5. And if I add -5 and +5 together, I do, in fact, make a 0 for the y coefficient. So we can go ahead and add these up because what happens is we're only going to be left with x's, which is something that we can work with. So if we add all the like terms together, -3x plus a -4x makes -7x, -5y plus a 5y makes 0y, and then -7 plus 14 makes a +7 because these are also like terms. Make sure you add all the pairs of like terms together. Now, if I look at what's remaining, 0y is nothing. 0 times anything is still going to result in a 0. So the y's have now eliminated, and all we have left are x's. And this is something that I can simply solve for. I know that if I want x by itself, I simply need to divide out the coefficient, and I get x is equal to a -1. So what we did was we eliminated the y's to get something only in x's, and then we solved it for x. So now we know that the x-coordinate of this solution will be -1. So now we just need to figure out the y-coordinate. Well, we're going to substitute -1 back into one of the original equations from the beginning. Doesn't matter which one, I'm going to pick the bottom equation because there's less negatives. Except now we know what x actually is. X is equal to -1. So we're going to replace x with -1. So we have -4 times x is a -1 plus 5y equaling 14. So now the only variable we have is a y. So this is something that I can solve. So we're going to multiply -4 and -1 to get +4 plus 5y equals 14. Subtract the 4 from both sides to try to get y alone. So 5y equals 10. And then divide out the 5 and have a y value of 2. So your final solution to this is the coordinate x comma y, -1 comma 2. So pause the video, see if you can try example 2 by following the same general idea. But remember, we're looking for a pair that adds up to 0. Doesn't matter if it's the x's or the y's, we just want a pair of numbers that will add up to be 0. And here's your solution for number 2. So we saw that the x's both went to 0 because 4 plus -4 is a 0x, so we would be left with y's only. And when we solved for y, we got y was -3/2. Now, it doesn't matter which one you substitute into. Take this y value and plug it into one of the top equations. I substituted it into the top equation because I knew if I multiplied 3/2 by a 2, the fraction would go away. And so when you substitute the y value in, you should end up with an x value of -1. So your solution is the x first, so -1, comma the y, -3/2. Now let's look at example 3. So what happens if nothing adds to 0 right off the bat? Well, 6 and -2 add to 4, so that's not going to eliminate. 5 plus -3 adds to a 2, which is also not going to eliminate. So we're going to have to kind of do some magic here and make this add to 0. Pick a variable x or y. It really doesn't matter. I'm going to choose the y variable here. I'm going to choose the x variable here. And the reason is because I need to think about how do I need to have the same number but opposite sign. That's what you're looking for. So you need the same number, opposite sign. Now, We cannot make a 6 into a 2 because we'd have to divide and it gets hairy with some fractions and that's not good. So we're going to stick to multiplication. So I can't make a 3 into a 5 by multiplying. 3 and 5, 3 does not have a common number with 5. However, I can make a 2 into a 6. So I'm going to multiply the entire bottom equation left and right by 3 because I know that if I multiply 3 times a negative 2, I will end up with negative 6, and that creates this being able to add to 0. But again, because math is all about the balance, whatever you do to the left, you have to do to the right. So this top equation, we are not changing. I'm going to rewrite it. 6x plus 5y equals 19. The bottom equation is going to be multiplied by a factor of 3. So 3 times negative 2x is negative 6x. 3 times negative 3y is negative 9y equals, and then 3 times negative 5 is a negative 15. So what we've done then is now if we look at this one more time, I can see that 6x and negative 6x will add up to be 0 x's. So you have eliminated your x's. Now the rest of it continues. 5y plus a negative 9y is a negative 4y equals, and then 19 minus 15 makes a positive 4. Well, 0x is nothing, so we really just have negative 4y equaling 4. So solve it for y by dividing out the 4, and we get y equals negative 1. So that's the y-coordinate of our solution. We still need to find x. So what we're going to need to do now is pick one of the two original equations. Don't use the one that you messed with because those are larger numbers usually. Let's go back to the original equation and decide where we want to put the y value of negative 1. I like the top equation because there are less negatives to worry about. So I'm going to put the y value of negative 1, I'm going to substitute it for y in the top equation. So this top equation is now 6x plus 5 times y is really negative 1 equaling 19. And again, all I have now are x's. I don't see any y's in here, so this is something that I can actually solve. So 5 times negative 1 makes negative 5. So 6x minus 5 equals 19. Add the 5 over, and we get 24. So 6x equals 24. And then divide out 6. So x is equal to a 4. So my solution is the x value of 4 and the y value of negative 1. So pause the video and try example 4 on your own. And here's what you should have had for example number 4. So the easier variable to eliminate in this case were the x's, because I can simply change a 1 into a negative 2 by multiplying by negative 2. There's no number that I can multiply a 2 by to create a 3. And so by multiplying the entire bottom equation by negative 2, I have created a pair of x's that will add to be a 0. Combine your like terms in both equations and solve for y. Substitute y into one of the original equations to find your x. So now let's look at number 5. So for number 5, currently nothing adds to 0. So if I add 3x and 5x, I get 8x. And if I add 4y and 6y, I get 10y. And so none of these add to 0. So I need to do this process again to try to create a 0 as a coefficient. Now, I cannot multiply 3 to get me a 5. I also cannot multiply 4 to get me a 6. So what's going to happen is we actually have to multiply both equations by a number in order to get something to add up to be a 0. Now, it doesn't matter which one you decide to eliminate. We can eliminate the x's or the y's. Either one will give us a correct answer. We need to decide. So I'm going to decide on getting rid of the y's. And the reason why I want to get rid of y's is because I know that the lowest common multiple of 6 and 4 is a 12. The lowest common multiple of 5 and 3 is a 15. So 12 is a little bit smaller number than 15 for the x's. So now that I've decided to eliminate the y's, first is we need to figure out 4 times what number will give me a 12? Well, I know that 4 times 3 gives me a 12. So I'm going to have to multiply by 3 on the left and the right. And for the bottom equation, I need to know 6 times what gives me a 12. So I know that 6 times 2 will also give me a 12. Now, before you multiply, remember, we need the same number but opposite signs. So the way we have it currently, 3 times 4 is a positive 12, and 2 times 6 is also positive 12. I need one of these to be a negative number. Again, it doesn't matter which one, so I'm just going to make the 2 a negative 2. And now if I do negative 2 times a positive 6, I end up with a negative 12. So I have one 12 and one negative 12. So now let's multiply and make sure this is going to work. So 3 times 5x makes 15x. 3 times 4y makes 12y, equals 3 times negative 14, which makes negative 42. And on the bottom, we have negative 2 times 3x, which makes negative 6x, negative 2 times 6y, which makes negative 12y, and 6 times negative 2, which makes negative 12. So we need to make sure, do our y's actually add to 0? And in this case, they do. If I add these two together, they will make a 0. So now I can go ahead and add these up. So 15 plus a negative 6 will be 9. 12 and a negative 12 makes 0y. And then negative 42 plus a negative 12 will give me a negative 72. Well, these are gone now. So now let's add them up. 15x plus a negative 6x is a 9x. 12y plus a negative 12y is 0y. And negative 42 plus a negative 12 is a negative 54. 0y isn't really there, so all we really have is 9x equals negative 54. And simply divide out the 9 to get x alone as negative 6. So now we need to substitute this negative 6 back into one of the original equations. However, make sure you go to the original. These numbers are smaller than the ones you manipulated. So always go back to the original equations. I'm going to choose the bottom one because it has a lot smaller numbers. So 3x plus 6y equaling 6, but we now know that x is equal to a negative 6. So 3 times negative 6 plus 6y equaling 6. And we're going to go solve this for y. So 3 times negative 6 makes negative 18. Plus 6y equals 6. We're going to add the 18 to both sides. We get 6y equals 24. And then simply divide out the 6 to get a y value of 4. So your final solution is an x value of negative 6 and a y value of 4. Pause the video, see if you can try example number 6. Here's what you should have had for example 6. So on the left, we eliminated the x's, and on the right, we eliminated y. So either method is going to give you the same answer no matter which variable you choose to eliminate. So if you eliminated x, please check your work with the steps on the left. If you eliminated y, please check your work with the steps on the right. Let's talk about some special solutions for systems of equations. So when all the variables add to 0, we do not have anything left to solve for. So this leaves us to evaluate the expression that is left. So that can be 0 equals 0, 2 equals 4. That's what I'm talking about. That piece that's left over after you have all your variables eliminate, we need to see if that's true or false. So if it's a true statement left over, that means we have infinite solutions. No matter what x or y is, you will always get a true statement at the end. If it is a false statement, we have no solution. So there's no value of x that will ever give you something that is true. So let's look at the example number 7. So for example 7, it says solve the following system of equations by elimination. And so again, you can decide, do we want to get rid of the x's or get rid of the y's? Well, trying to make a 2 into an 8 is possibly easier than 8 into 32. 32 is a pretty large number, so I'm going to stick with these guys here. So I'm going to choose to eliminate the x's, which means all I have to do is multiply the top equation by a negative 4, because I need it to be a negative 8. I need a positive 8 and a negative 8. So negative 4 times 2x is negative 8x. Negative 4 times 8y is a negative 32y. Equaling 6 times negative 4 is negative 24. And for the bottom equation, we didn't mess with it. The bottom equation was fine the way it was. So now we need to check, did I truly eliminate the x's? And yes, I did. Negative 8x plus 8x makes 0x. Well, negative 32y plus 32y is 0y. And negative 24 plus 24 also makes a 0. So I got lots of zeros going on. Well, 0 times x is still just 0. Plus 0 times y, no matter what y is, will always be 0. And 0 plus 0 makes, so there's no variable left to solve for. I've got 0 equaling 0. So since all of our variables have been eliminated, we need to decide, is 0 truly equal to 0? And yes, it is. So we have a true statement left over, which means that there are infinitely many solutions to this system of equations. There's not just one coordinate point that works as a solution. There's an infinite number of coordinate points that will work as solutions. Now, number 8, it says solve the following systems by elimination. But actually, this is set up for substitution. And we know this is set up for substitution because it has a y isolated by itself. So we're going to kind of switch gears here, and we're going to solve this with substitution. So we're going to replace y. Instead of eliminating, we're going to replace it with something else. So the top equation now turns into negative 18x plus 6 times, we are replacing y with 3x plus 2 equaling 24. But as you notice, we still got rid of the y. We didn't eliminate it, we just replaced it with something else, but it's still now all in x's. So now that we have substituted, let's continue to solve this for x. So 6 times 3x makes 18x, 6 times 2 makes 12, equaling 24. Combine like terms, so negative 18 and 18 combine up to make a 0x plus 12 equals 24. But remember that 0 times anything is still 0. No matter what x is, 0 times whatever x is will always be 0. And 0 plus 12 makes 12. And so again, we are left without any variables to solve for. So we need to decide, is 12 equal to 24? And it's not. So this is a false statement. And when you're left over with something false, we say that there is no solution. So there is no coordinate point that these two graphs will share. These two linear functions will never share a coordinate point.